Engineers, planners, geologists, miners, and many other professionals work constantly, tirelessly, tenaciously, with precision and skill, 24 hours a day, 7 days a week, on one of the cross-border projects of the century, the Brenner Base Tunnel. All the different groups working on the construction sites and in the offices are like gears that mesh to drive this infrastructure project forward. Implementation takes place step by step, like the steady ticking of clockwork. The Brenner Base Tunnel is one of the largest infrastructure projects in Europe, as well as the longest underground railway connection worldwide. A goal Austria and Italy are working towards together is a project that will unite Europe. Once the tunnel goes into operation, the travel time for passenger and goods trains between Innsbruck and Fortezza will be significantly reduced. Travel time for passenger trains will be cut from 80 to 25 minutes. North and south of the Brenner Pass, this will be a significant improvement for residents and travellers. If you want to get past a mountain, there are two ways to get to the other side. Either by travelling over it, with many steep curves uphill and downhill, or going straight through it, underground. A lot of people are working on the Brenner Base Tunnel to build the direct underground railway connection between Innsbruck and Fortezza. A railway tunnel at the base of the Alps, offering the advantages of a flat railway over a total length of 64 kilometers. The Brenner Base Tunnel comprises more than 220 kilometers of tunnel tubes. Two main tunnels for the tracks with a diameter of about 8 meters and a cross passage every 333 meters. Between those tunnels and 12 meters below is a third tunnel, the exploratory tunnel, which is 6 meters in diameter. This is driven first to understand the nature of the rock mass and to find out exactly what kind of rock is to be expected. Once the Brenner Base Tunnel has become operational, this tunnel can house technical equipment and be used to carry out maintenance work. The 4 lateral access tunnels in Mühles, in Steinach am Brenner, in the Arental Valley, and in Ampass are necessary to advance deep into the mountain and excavate the tunnel system from there, on several construction sites simultaneously. By mid-2023, 160 kilometers of tunnels have already been excavated, which is more than 70% of the total. In Fortezza, the southern entrance to the Brenner Base Tunnel has been clearly visible since 2018. In Innsbruck, the northern entrance is under construction in the complex Sill Gorge construction lot, which includes the connection to Innsbruck station. Extensive rock protection works and slope removal are only part of the measures aimed at building a modern railway line here and improving an important local recreational area. A team of engineers, surveyors and geologists constantly monitors the behaviour of the rock mass. Nothing is left to chance. Construction management plays an important role in ensuring that construction proceeds safely and successfully. The tunnelling methods used are state-of-the-art. Special attention is paid to environmental compatibility and sustainability. For example, when crossing under the Isarco River near the South Portal in Fortezza, the entire ground in the driving area was frozen with liquid nitrogen so as not to have to change the course of the river. The effort involved was enormous, but the strategy was very effective. High-tech machinery and technical expertise are needed to ensure that impacts on nature are kept to a minimum. The shafts required for this have already been backfilled, and the construction site area is being dismantled. In the meantime, the Isarco River underpass has even been connected underground with the largest construction lot along the Brenner Base Tunnel, Mühles. This provides a continuous connection from the southern portal of the BBT to the national border at the Brenner Pass. Focus on nature. Environmental impact assessments are the basic requirement for the project. In order to compensate for the short-term impact and repercussions, accompanying environmental compensation measures will be implemented along the project area with local partners in compliance with the highest environmental standards during construction. This is where the environmental experts and landscape designers come in. People who can ambitiously and just as sensitively rehabilitate a stream bed, as for example at the Renanobach near Vipiteno. Create a biotope in the Kosher Au. Create fish-friendly conditions in watercourses, as in Navis or on the Sill, where obstacles that are insurmountable for fish are removed. Or create a small recreational oasis, the Tantigut Moor in Innsbruck. Using the motto connecting and protecting, the Brenner-based tunnel company has also designed an information path in the Padastra Valley in Tyrol, which emphasizes the importance of sustainability in the BBT project. Sustainability is also a priority for the construction of the Brenner-based tunnel. For example, long tunnel sections are excavated mechanically with highly efficient tunnel boring machines, or TBMs for short. After the logistically demanding transport and no less demanding assembly in the confined space inside the mountain, 200 to 400 metre long mobile tunnel factories are created, which then work their way through the rock. In the TBM's backup structure, the precast concrete parts for the inner shell, the so-called tubbing rings delivered on rails, are unloaded and transported further forward, where they are assembled into a ring. Even further forward is the rotating drill head, which cuts through the rock with its numerous cutter bits. In the control room, the TBM operator pays close attention to the direction and ensures that everything moves smoothly. Jacking, segment removal, pull-up of the TBM backup, regular checks and maintenance work on the drill head, and then, once again, jacking, segment removal, and so on. The finished tunnel increases in length on average by 15 to 20 metres in 24 hours, depending on the rock conditions. The exploratory tunnel section in Austria was excavated with a machine whose drill head was used as an exhibit piece in Tunnel World in Steinach am Brenner. Also in Austria, Lilia and Ida are currently driving the main tunnel tubes. The precast concrete elements that are installed by the tunnel boring machines are produced directly on-site at the construction site. This avoids tens of thousands of truck transports. In Italy, the tunnel boring machine Virginia has already reached the national border in one of the main tunnels. And the exploratory tunnel has also been completed by TBM Serena up to the Brenner Pass. When excavating short tunnel sections, such as access tunnels, rescue tunnels, and cross tunnels, it makes no sense to use tunnel boring machines. More conventional methods are used in those cases, with drilling machines, explosives, excavator buckets, steel grills, and shotcrete. Although heavy equipment is a great help to the miners in their work, a lot of manual work is still required. The two large connecting tunnels in Austria which link the Inn Valley with the Vip Valley were also excavated using blasting. Since rail traffic in Austria uses right-hand driving, whereas in Italy left-hand driving is customary, two overlapping tunnels were built deep in the mountain. This allows for uncomplicated crossovers with no need for complex switch controls. Drilling and blasting was also used to excavate a fault zone in the northern Viptal Valley. There, the so-called Hochstegen marble had to be stabilized by means of numerous stabilizing injections in order to be able to safely excavate this limestone, which was under high water pressure. Logistics is the be-all and end-all in tunnel construction, because the construction site deep underground is reached via an access tunnel, the main artery of every construction lot, so to speak, to enable the construction of the railway tubes in the first place. High-speed trains will one day roar through these main tunnels. At present, rail-bound supply trains still move through at regular intervals, carrying people and materials to the excavation fronts in order to drive construction forward. Whatever the manner of excavation, the excavated material is removed in both countries via 80-kilometer conveyor belt systems and taken directly to landfills. One of them is located in Eicha, South Tyrol. Another in the Padaster Valley in North Tyrol. This means that not a single lorry journey through villages is necessary. Up to 1/3 of the excavated material is recycled and used for concrete production. Everything else melts into the landscape, creating cultivable land and turning a steep valley in Steinach into a recreational area. And on the subject of security, the client, BBT SE, and the construction company rely on numerous safety devices, such as self-sufficient escape containers, in which an entire excavation team is protected even against the greatest dangers in a tunnel, fire and smoke, until rescue workers can reach them. Regular drills train both workers and rescuers. For local residents and other interested parties, however, many things remain invisible and hidden. All the more reason for us at BBT SE to focus on multiple information and communication channels, organising tunnel and construction site tours, setting up information centres, and providing reports. Our commitment to fast, modern and efficient transport routes protects our climate and promotes rail as the mobility of the future. Our work will benefit local residents and the entire population of Europe for many generations to come.